An improper fraction, right? An improper fraction is when the numerator is bigger than the denominator. Okay, so in every fraction, there are two numbers. What does this bottom number tell you in a fraction? Go ahead, Alicia. Yeah, how many parts there are in one whole? How many parts one whole is split up into? That's what the denominator, the bottom number, is. Okay, so every whole has 4/4 in it. Every whole is split into 4 parts. Okay. This top number tells you. Go ahead, Alicia. How many of these fourths you have. Okay, so if the top number is bigger than the bottom number, then it's more than one whole, right? That's what makes it an improper fraction. The top number bigger than the bottom. And so the top number bigger than the bottom means that I can rewrite this as a mixed number with a whole number part and a fraction part. And you should have, when you learned all this stuff back in 5th grade, done like a little demonstration here of, it's a big improper fraction, but. Okay, so how many 21/4? That means I got to draw enough of these to have 21 of them shaded in, right? So here's 4, 8, 12, 16, 21, right? So 21 of these fourths are shaded in. 1, 2, 3, 4, 5 wholes and 1/4, right? Which is the mixed number equivalent of 21/4. Okay, so this is all what you should have done in 5th grade when you learned this. Okay, converting an improper fraction to a mixed number. So what you do is, how many times does 4 go into 21? Right? How many times does 4 go into 21? Or in this first problem here, how many times does 4 go into 41? Well, you think of your 4 times tables until you run out. So it goes in 40, 4 goes into 40, 10 times. 10 times. I forgot to fix this. 10 times. Right? Which means this is 10 wholes, and then how many are left over? Right? How many are left over is 1. So 10 and 1/4. Going the other way, if you have 3 wholes and you're splitting all your parts into halves, well, 3 wholes is going to be 6 of those. 3 times 2. So 6 halves makes up the 3 wholes plus 1 more. Means 7 halves is the same as 3 1/2. Next review thing. Oops. There was all the answers. Simplifying a fraction or writing a fraction in simplest form. How do you know a fraction is in simplest form? Roman.
When you can't divide it into smaller pieces.
Right, when you can't divide the top and the bottom by the same number anymore. Okay, so as long as the top and the bottom of the fraction, the numerator and denominator, as long as they are both divisible by the same number, you can divide by that number and simplify the fraction. Okay, so 25 over 100, 25 and 100 are both divisible by 25, and that simplifies to 1/4. All right. Now there's different ways to do this. The way you learned it probably the first time in 5th grade was to find the greatest common factor. There's this long process of figuring out what the greatest common factor is, the biggest number that goes into both of these. That's a pain. I don't ever do that. Okay. I prefer to just use the divisibility rules to make it like, okay, look for what easily can I find that both that the top and the bottom numbers can be divided by. Okay. So 40/50ths, what does that simplify to? You can write these on the side of your paper somewhere if you want. These are not in the book. 40/50ths. Roman.
8/10, actually. 4 through 4, 8/10.
Okay, so how'd you get 8 tenths? Divided both of them by 5, right? Now, how did you know that they were both divisible by 5? You just kind of knew? What bigger number than 5 are these both divisible by? Marcus? 10. Okay, what's the rule? When is a number divisible by 10? Marcus? If it ends in a 0. Okay, if a number ends in a 0, it is divisible by 10. So if you divide both of these by 10, you don't have to write this ever, right? You just write your answer. Divide by 10, you get 4/5, which you would have gotten, Roman, because 8 tenths is not simplified. 8 and 10 are both still divisible by 2. All right, next one, 35/60ths. 35/60ths. Did someone raise their hand at home? Who is that? James Tweed?
Me.
Who? Nate?
Yeah.
Okay, what are 35 and 60 both divisible by?
5.
5. How did you know? So 35 divided by 5 is 7. 60 divided by 5 is 12. How did you know they were both divisible by 5?
Since a few times 5 by 2 would equal 10, so if you did that like a few more times, it would be 60.
Okay, so numbers that end in what or what are divisible by 5? If it ends in
0 and 5.
0 or 5, that's the divisibility rule for 5. Both numbers end with a 5 or a 0, then you can divide them by 5. All right, next one, 12/14. Evie, what are 12 and 14 both divisible by? 2. How do you know that? Because they're both even. Okay, so when the numbers are both, very good. So when the numbers are both even, they're divisible by 2. You should be able to divide any number by 2, no matter how big it is, right? To divide it in half. So divided by 2 gives you 6/7. And again, you don't have to write this, how you get the simplification, but that's how you get it, right? These were both, divided by 5. Okay, that's how you get them. Oy, oy, oy. Okay. 27/33. Kenny.
I know they're both divisible by 3.
Yeah. Now these numbers are in your 3 times table, so you probably recognize them that they're both divisible by 3. If they were bigger numbers than 27 and 33, okay, like let's say it was 273 and 339. That's not even a good example, because you'll say something wrong. Does anyone know what the rule is for divisibility by 3? 321 over 612. Okay, are both of these numbers divisible by 3? I don't know. Gosh, how do you figure that out? Marcus, do you know the trick? Anybody? Roman? What is the rule for knowing whether a number is divisible by 3? Remember, Grayson? Maggie?
Isn't it like the n number is a 3?
Not the n number. If you add these digits up and the answer to that is divisible by 3, then the whole number is divisible by 3. Right? So 3 plus 2 plus 1 is 6. Check. 6 plus 1 is 7 plus 2 is 9. Check. Right? So that's the divisibility rule for 3. It's some people remember it, some don't. Okay? If you remember it, it makes simplifying things easier, because a lot of numbers are divisible by 3. Every third number is divisible by 3. That's a lot of numbers. Okay? That's the trick. All right, so what happens here is you might want to try to find the most common, the biggest number that these things are divisible by, I don't require you to do that. I don't do it. I look for these simple rules and see if I can figure out what, and then just keep simplifying, right? So 120 over 135, what are those divisible by? Matt? Yes, they're both divisible by 3. That's true. Okay, because he did that trick. I would have gone with a bigger number than that first. What else are these two numbers divisible by? Evie? 5, because they end in a 0 or a 5. If it's divisible by 3 and divisible by 5, what is it divisible by? If it's divisible by both 3 and 5, that means I can divide it by 15. Right? If it's divisible by 3 and divisible by 5, I can divide by 15. Okay, which, not that you can do that in your head, right? But anyway, there's the problem with simplifying fractions is a calculator doesn't always help you. Okay? Doesn't always help you. You have to know what numbers to divide by, and figuring that out can be a problem. All right, 240 over 400. What's the first easiest thing to divide by here? Chad? 240 over 400. I'm trying to simplify that. 10. They're both divisible by 10 for sure, right? So you just take a 0 off. 24 divided by 40. Now what? Roman? 2. Now there's a bigger number than 2 that these are divisible by, and maybe you might get it because they're, you know your times tables, okay? But let's say you didn't, and you're just like, oh, they're both even. I'll divide them by 2. And you get 12 over 20. And now this is 2 again, right? That's going to be 6 over 10. Oh, man, they're still both even. Divide by 2 again. 3/5. Okay? This is perfectly fine if you do this. Okay? Now, some people over here said, hey, these are both divisible by, because they know their times tables. Marcus? 24 and 40 are both four, even bigger than 4. 8, right? Which you could have figured that these were both divisible by 8 and gone directly to 3/5. Okay? If it's divisible by 2 and then by 2 again and then by 2 again, that's divisible by 8.
2/3.
2/3, because these are both divisible by 12 if you kind of know your 12 times tables. If you did it and you divide it by 2, like Ava wanted to do, I think, and you get this, then maybe you recognize that 12 and 18 are divisible by 6, or maybe you don't recognize that and you divide by 2 again and you get 6/9, and then you say, oh, 6 and 9, they're both divisible by 3, and then you get 2/3, right? So the bigger the number you find here, the less steps you have, but you should be able to get to this final answer either way, okay? Number two. Okay, Alicia. 9 over 10, both divisible by 5. 9 over 10. Number 3. You know your times tables here, otherwise you got big problems on this one. Because 121 is only divisible by one number besides 1. Which is what? 11. 11 times 11 is 121. So this one is tough. These are both divisible by 11. I'll tell you that if you ever see, you know, the number where it's 2 digits, 22, 33, 55, 66, right? That's your 11 times tables. Just check 11 on both of them to see. They're both divisible by 11, giving you 8 11s. 11 is a prime number. That's correct. And 121, because it's 11 times 11, that's the only number that it's divisible by. It's not divisible by any other number, 121. All right, graphing on the number line. If we weren't in COVID here, I would have someone come up and put their dots on here, all right? But when you graph a fraction, when you think about where the fraction is on the number line, you have to split in between the whole numbers. You split them into this many parts, whatever the denominator of the fraction is. So if it's halves, then you split your whole shape here into 2. And then you count off this many. So 1/2 is right here. 3/4 means I have to split between 0 and 1 into 4 equal parts. And I'm going to count off 3 of them. So that's 3/4. If there's a number in front, you go to that number first, and then between there and the next whole number, you split it into this many parts. And you count 1 more of them. So 1 1/4 is right here. And lastly, 2 1/2. Should be halfway between 2 and 3, like that. Okay? That is 5th grade, 6th grade. 5th grade, probably. Okay? How am I going to turn these fraction problems into 7th grade fraction problems? Roman.
And variables.
That's true. That would definitely do it, but it's a little bit simpler than that.
And we have phone cases.
A little simpler than that. The unit we just finished, now we can start doing that with these fractions, which is make them negatives, okay? So negative fractions now makes this a 7th grade topic, okay? So graphing negative fractions on a number line, how's that going to be different than graphing positive fractions on a number line? Marcus?
It's just below 0.
Yeah, so it's below 0, and you're going to go to the left as you're getting bigger instead of to the right. Okay, so to graph negative 3/4 is between 0 and -1. So everything goes backwards when you're going negative, right? So 0 is here, and -1 is to the left. Because it's fourths, I split it into 4 equal parts, like we just talked about. Okay, and so we can start shading here. 1/4, 2/4, 3/4 going in the negative direction. And that means that this is where negative 3/4 is going to be. And I put a dot on there. Okay. The book will give you that. So this is 1/4 and 2/4. Okay, great. And there's your answer. Okay. So on the number line, negative 3/4 is between negative 2/4 and -1. Okay, or between -1 and a half, -1/2. You just have to remember that everything goes backwards when you're talking about negative numbers. Okay? Fancy words. All right, so any fraction can be expressed as a decimal. Every fraction has a decimal equivalent. Okay? It could be a repeating decimal, meaning there's numbers that just go on and on and on forever and never stop. It could, and those are written with bar notation, which you've seen before, right? 0.858585. You don't keep writing 85, you just put a bar over them, called the repeating bar. Or it might be a terminating decimal. It ends. Okay, or the repeating digit is a 0 at the end, which no one ever writes that, right? You typically just end the decimal. Okay, so a decimal that has an end is a terminating decimal. It terminates. The Terminator, right, was the guy who ended people's lives, right? Or if you're at the bus and when you get to the end of the bus ride, you're at the bus terminal. Yeah, the bus terminal or train terminal. Sometimes they use station, but terminate means the end of something. Okay. All right. So you can do this little which one of these has the bar notation in the right place. I'm on page 263 now. Sorry, we moved to a new lesson. Page 263. 0.111111. Which one is that over here? Chad? .1111111111. Which one is over here? What does that match up with? This one, this middle one, or the middle one? 0.1 with a bar over the top. Okay, so this one goes here. 0.611111111. Kenny?
Top.
The top one, because the 6 is not repeating, right? Only the 1. So the bar only goes over the 1. If both of them are repeating, 61616161, then the bar goes over both, right? Okay? So you'll have practice with this stuff as we move along today. All right, so fraction divided by 9 in your calculator is 0.2222222. It goes on forever. Okay, so we can write it with bar notation. What's that going to look like? What's happening here? 0.22222 with bar notation. What's that going to look like? Riley?
0.2 with a bar.
0.2 with a bar over top, right? Like that. Okay. We don't normally in real world problems report numbers like this. We'll round them off to some number of decimal places. Batting averages are typically always rounded off to 3 decimal places to the nearest thousandth. So what is this person batting? What's their batting average? Rounded to the nearest thousandth. Marcus? So the nearest thousandth is how many decimal places after the decimal point? 4? This is the what's place? Tenth. This is the hundredths. This is the thousandths. It's a very common mistake to think that 1,000 is 4 because on this side, the thousandths is the 4th number on the whole number side. But on the decimal side, tenths, because there's no ones, right? Tenths, hundredths, thousandths. So rounded to the nearest thousandth, this person's batting average is 0.222, and done, because that's 3 decimal places, right? And we don't round up because this 4th number is less than 5. Okay, so 0.222. That's a real world example of converting fraction to decimal. Okay, decimals are tenths. Factors of 10. There's the tenth, there's hundredths, there's thousandths, and of course you can keep going. So if you have a fraction that's already in tenths or hundredths or thousandths, you can just rewrite them as a decimal. 7/10 as a fraction looks like this. And as a decimal is 0.7, 7/10. 19 hundredths means 19 over 100. And what does that look like as a decimal? Roman? 0.19 or 0.19. Let me point out right here, there are some math teachers that would not be happy if you wrote your answer like this. Why would they be unhappy with your answer written like this, Roman?
You don't have a 0.
Because I didn't put a 0 in front of the decimal point, okay? This is a matter of preference for math teachers. Some math teachers think it is really important to put that leading 0 in front of the decimal point. This math teacher does not think that that's important because I never write it when I write a decimal. I just say 0.19. I don't say 0.19, okay? Next year, you might have a math teacher that requires you to write this 0 in the front. This one does not. So you can write it either way. If you write 0.19, you get full credit. If you write 0.19, you get full credit, okay? Really more officially correct this way, but I don't worry about it. Yes, Roman?
Why is there no ones place?
It just doesn't work that way. There is no once. Yeah, it just doesn't work that way. Okay, 105 thousandths, so 105 over 1,000, which can be simplified. You divide both of these by 5, right, because it ends in a 5 and a 0. you get 21/200ths, but this doesn't help me write this as a decimal. What is 105 thousandths as a decimal? Marcus,
0.105.
0.105. Boom. Okay. So tenths, hundredths, thousandths, very easy to write them as decimals. I will post an extra help video on this type of fraction to decimal conversion if you're having trouble with it. Okay. These are not that common though. Most of the time your denominators are not tens or hundreds or thousands, right? They're other numbers. Now, if you could make the denominator a 10 or a 100 or a 1,000, then you could write the decimal very easily like we just did. That's one way to convert fractions to decimals. It is a pain that way, okay? Unless the number in the denominator is very easy to make into 100 or 1,000 or 10, which this one already is, right? So it's 0.74. Don't have to do anything there. But 7/20ths, okay? Well, if I wanted to make the bottom 100 here, multiply by 5, and you could do it that way. Most people would see that. Okay, so if you multiply both the top and the bottom by 5, you sort of unsimplify the fraction to make the denominator 100, and then you get 35/100ths, which is 0.35. Okay, so this is one way to do these, especially if you didn't have a calculator. Yes, Marcus?
You could divide it by half.
You can also divide it by half, and then you get 3.5 tenths. That's, I mean, yeah, you could do it that way. Okay, I mean, the math works, but it's a little bit weird. Now, some people that aren't that great at math, I don't want you to be spending a lot of trying to figure this stuff out. Okay, so we'll do a different method that will work for everybody. Okay, however, most people should know some of these basic fractions and what their decimal equivalents are. Okay, there's ones that you should just know. You shouldn't have to use a calculator or figure out what they are. You're just supposed to memorize what they are. Okay, 1/2. What is the decimal equivalent of 1/2? Roman? 0.5. A quarter, 25 cents, right? And 3/4, 75 cents, 0.75. Okay, 1/3. Not just 33. Evie. 0.3. 3. It never ends. So you round it off to 33 or 33 1/3, but it's really the actual specific exact decimal is 0.3 repeating. 1/3 is 0.3 repeating, and 2/3 is, Marcus, 0.6 repeating. These are the ones that people have the most trouble remembering. You should know them. How about fifths? 1/5 is the same as how many out of 100? Evie? 0.20? Correct. 0.2. Every fifth is 0.2 because 20, 40, 60, 80, 100, there are 5 20s in 100. Okay? So 2/5 is 0.4, 3/5 0.6, and 4/5 0.8. It's good to know these. You can remember them. Okay, tenths, we already talked about those. 1/10 as a decimal, 0.1, 3/10, 0.3, 7/10, 0.7, 9/10, 0.9. Okay, you should know these. However, in this entire unit, you can use a calculator for all these problems. And so, if you don't remember 3/5, you can use the calculator to get the answer, which we'll get into here in a minute, okay? All right, nextly. These are ones that would be nice to know, okay? Some people know their eighths in a decimal equivalents of eighths, okay? An eighth is half of a fourth. An eighth is half of a fourth. Right? 1/4 split in half gives you 2/8. So 1/8 is half of a fourth. Well, 1/4 is 0.25. So 1/8 is half of that, which is, Marcus? 0.125. Half of 25 is 12.5, 12 and a half. So 1/8 is 0.125. You don't have to know these, okay? But it's nice to know if you're a good math person. Okay, so then you can just use this and add it on to the quarters, right? So 3/8 is 1/4 plus 1/8. So 25 plus 12.5 is 37.5. Okay, 5/8, 0.5 plus 0.125, 0.625. And 7/8 is 0.75 plus 0.125, 0.875. These are nice to know if you don't. 20ths. A 20th is half of a tenth. So each 20th as a decimal is half of 1/10, half of 0.10, 0.0, not 0.5, that's a half, right? 0.05, okay, 0.05, 5 100ths, because there's 25 goes into 120 tons, okay? So multiply by 5, right? That's how you get 26. You don't need to know any of these. You don't need to know any of them, okay? Because there's a method to get any fraction to a decimal very easily if you have a calculator, which you will, okay? So these problems, they expect you to do without a calculator, which a couple of them aren't too bad to do. 3/10. Marcus, 0.3. 6.5 negative. Okay, what do I have to do in my answer if this fraction is negative or this mixed number? Then the decimal also has to be negative. Okay? What's negative 6.5 as a decimal, Matthew? Negative 6.5, because a half is 0.5. Okay, this one a little trickier. Got it? 3/25 as a decimal without using your calculator? Denny?
0.15.
Close. Okay, how did you try to get this to, can you make this 25 a 100? By doing what? Multiplying by 4, okay? So if I multiply this by 4 to get 100, what do I have to do to the top? Multiply by 4, and I don't get 15, I get 12, okay? So 3/25 is 0.12. I don't expect you to do that without a calculator. I wouldn't ask you to do that. It's not that important to be able to do, okay? But what is important to be able to do is to do all these types of problems with a calculator, converting a fraction to a decimal, okay? So that's where we're going to go next. The book continues to say you don't have a calculator. And so if they want you to do 3/8, they're like, okay, here you go, long division. Oh, what do I say to that? Yeah, I say I'd rather my students use a calculator than waste their time doing long division. Right? Because you pretty much have a calculator. It's how you're going to do these. Yes, Roman?
Why is it 0.375?
That's what 3/8 is as a decimal. Why are you asking why? You think it should be something different?
Oh, no, I just need to figure out. I thought 0.375 was in place of 3,000.
That was bad. Am I back? Long division, 3 divided by 8, you have to add a decimal point and then just keep adding zeros so that you can do it. We're not going to do this long division, okay? Yeah, it'd be nice if you knew how to do it, but it's not worth the time, okay? So instead of doing all these with long division, we're going to skip over and do them again, Xing out all the long divisions and using a calculator. This is how you're going to do these problems, okay? Every fraction is a division problem. We've been saying that since the first week of school. This is how I write division problems now. 3 divided by 8. So in your calculator, 3 divided by 8. 3 divided by 8, enter. 0.375. The calculator doesn't even put a 0 in front of the answer, right? So I don't feel so bad.
It doesn't really matter because 0 means nothing.
You're right. Again, some math teachers get kind of bent out of shape about that. Okay? So this is how you can do any fraction as a decimal. Divide numerator divided by denominator. This one is negative 1/40th. Negative 1/40th. Okay? Do I need to put a minus sign in my calculator to figure out what the decimal is of negative 1/40th? No. I know the answer is going to be negative, so I'm not going to bother typing the negative number in my calculator. I'm just going to do 1/40th and put a minus sign in front of whatever the answer is. Okay? You don't need the negative sign in your calculator. Just add it at the end. So, break out my handy dandy calculator and I do 1 divided by 40. Enter. 0.025. Negative, because the 1/40th was negative. Okay, so that's how we get this guy. Negative 0.025. All right, last one. 7/9. 7 divided by 9. Enter. 0.777777778. Is this a repeating decimal?
No.
Why do you say no, Roman?
Is the turning decimal?
Okay, because there's an 8 at the end, he says. Okay. This is a calculator, right? And it has a display of a certain number of digits. What do you think the calculator does if this number keeps going and the calculator runs out of room to display the number? Evie. The E thing is when the number is too big, okay? That's called scientific notation, which you will learn next year, right? It's not that the number is too big here, it's that this decimal just keeps going. So you're right. If you multiply two numbers together, you get some number that's really huge, bigger than 10 digits as a big number, you'll get an E in your answer. Okay, which means that's how many like decimal or places to add on to. You'll learn it next year. It's called scientific notation. Okay. But decimals, it wants to just keep writing the sevens all the way out, but it can't because it runs out of space. So it's thinking, okay, 7, 7, 7, 7, 7, 7, 7. There's still sevens that go to the end. But at the end of the display, what is the calculator doing? Why is it writing an 8 here? What is it doing at the end of the display? It starts with an R, the word that it's doing.
Round.
Nope. Rounding. It's rounding at the end of the display. Okay. It's like, I'm out of room. Let me go to the next one and see if it's a 5 or higher. Then I'll make this one higher, make it an 8. Okay. So this display, when you get this, can cause confusion. This 8 at the end is not, this isn't repeating anymore. It's that the calculator ran out of room and it rounds at the end. Okay. So the calculator rounds. So if the last digit is 1 higher than what you expect it to be, that's why. Okay. Yes, Roman.
On number 5, I actually was positive 25 because of our individual rules.
Well, so the minus sign in this problem is in the front of the whole fraction, right? Which means that you're basically doing this division first and then you're making the answer negative. If the negative sign was just on the top or just on the bottom, it would still be the same as this. We'll see that one in the next page, I think. Okay, so 0.7 repeating. 0.7 repeating is the answer to 7/9. Okay. All right, so let's do these 4 problems with a calculator, not long division, which is what all this space is here. We'll do them with a calculator. That one. Evie? -7/8 as a decimal?
I don't know.
Okay, how do we do this?
I don't know, that's why I don't know.
Okay, so this is a what kind of problem? 7/8 is what operation? Division. 7 divided by 8 in my calculator, which you are holding in front of you, which is why I thought that 7 divided by 8 equals 0.875. And because this is negative, the answer is negative. Okay? That's all you have to do for these. 2 and 1/8. What do we do with the 2? How do I put this 2 in my calculator? Do I put the 2 in the calculator? Anybody? You have 2 options here, the hard way and the easy way. What do you think the difficult way is to get this as a decimal? Well, put what in your calculator? How are we going to do that? Alicia,
I have a question.
go ahead.
If you did, because I don't know how to put this in the calculator.
Right, that's why we're talking about it.
But if you do, oh wait, no.
How can I make this a fraction that I can put in the calculator?
Oh.
Evie.
Could you like solve the fraction and then put the big number in
Yeah,
front of the decimal?
Not solve, but convert this to an improper fraction, which would be what? Okay, we could do improper fraction. What's the improper fraction of 2 and 1/8? 16 plus 1, 17/8. And if you do 17 divided by 8 in your calculator, don't do it yet. What do you think you're going to get in front of the decimal point when you do that? 17 divided by 8. What number is going to be in front of the decimal point in your, a 2? Okay, it's going to be 2 point something. 2 point. Kenny? 2.125. Okay, this is the long waste of time way to do this problem. Okay, this is the long way. What is the short way to do this problem? Evie?
Divide 1.8.
Okay, you divide 1 divided by 8, you get 0.125. Where does this 2 go? In front of the decimal point. You know it's going to be there, right? You know there's a 2 in front of the decimal point, so you just do this, and then you just do the fraction part. 1 divided by 8, and you get 0.125. And if it's negative, you put a negative sign in the front. -3/11. Oh, Kenny.
I'm not sure if I got this right, but -0.27, both the 2 and 7 are repeating.
That is absolutely correct. In your calculator, it looked like this. Possibly, depending on how many digits you get, right? It either ended in a 7 or it ended in a 3. Why did it end in a 3? Because it rounded this 2, because the number after it was a 7 and it rounded it up, okay? But Kenny's exactly right, okay? First off, he didn't forget there was a minus sign in the front. He said negative, I think he did, I don't really remember. Negative 0.27 repeating with the bar over both the 2 and the 7, because those both numbers are repeating together, 27, 27, 27. Good. Last one, 8 1/3. You should not need a calculator for this one. You should not need a calculator for this one because you know in front of the decimal point is going to be 8, and after the decimal point is going to be 1/3 as a decimal, what you're supposed to know is 0.3 repeating, okay? Put 1/3 in your calculator, 1 divided by 3, you get 0.33333. Okay? All right, I think that's it. Yep.